Okay, let's do some word problems. I know you guys are excited about word problems, but the fun thing is you can actually see some real application as to why we've been doing systems. They actually help you think through some real life situations. All right, so first problem, the sum of two numbers is 52. The large number is 14 more than the smaller number. What are the numbers? So we have two equations here. The trick is to pick them out. In the first sentence, it says the sum of two numbers is 52. So I have one number plus another number, they're potentially different numbers, equals 52. So we have first number is x and the second number is y. Okay, the larger number is 14 more than the smaller number. So let's say that the larger number will be x. So x plus 14 is going to equal, or that would actually be the other way around, but it doesn't matter. Let's say y is actually the bigger number and x is the smaller number. So I know that the smaller number plus 14 will be the same thing as the bigger number. So x can be the smaller number and y could be the bigger number. We probably have to keep track of that. X is smaller and y equals bigger. All right, so now we can use any of our techniques that we want to. And I'm looking at this one going, look, one of the equations is already solved for one variable. So I have something that I can substitute in the other equation. I'm going to substitute x plus 14 into y in the other equation. So here's what I have. X plus 14 instead of y equals 52. So let's go ahead and do this math. Those parentheses actually don't matter. Nothing's being multiplied together. So I can do x plus x is 2x plus 14 equals 52. Subtract 14. 2x equals 52 minus 14 is 38. Divide by 2 and get x equals 19. So my smaller number is 19, and then I know that if I have x plus y is 52, so 19 plus y equals 52, which means I'm going to be subtracting 19 to find out what y is. 52 minus 19 is 33. So I have 19 and 33. Let's see how we did. 19 is the smaller number. Oh boy, here we go with the internet. 19 and 33. Check. All right, number 2. A fruit company delivers its fruit in 2 types of boxes, large and small. That's probably going to be our variables right there. A delivery of 5 large boxes and 3 small boxes has a total weight of 99. Looks like situation number 1. And a delivery of 7 large boxes and 9 small boxes has a total weight of 171. Okay, so there are my 2 equations. The first one, so let's say that x is large and y is small. Okay, so 5 times x, that's the large, plus 3 times y equals a total of 99. Okay, at the same time, I have this situation. 7 times x plus 9 times y equals 171. All right, so now I have a system to solve, and I can choose any of my methods to use. So I think what I'm going to do, since this is in standard form like this and the x's are lined up and the y's are lined up, I'm going to multiply my top equation by -3 to make the y's cancel. So that will give me -15x. -3 times +3 is -9y equals 99 times negative 3. That's the drawback of this version. You sometimes get little bigger numbers. Okay, and then I'm going to keep my other equation exactly the same. I'm ready to add those together. These guys will cancel, which is really cool. And this will be negative 8x equals, I have negative 297 plus 171, which gives me negative 126 divided by negative 8. Gives me 15.75. Okay, it's not super nice number, but not totally unrealistic. And I need to use one of my equations to find out what the small boxes weigh. So this would be a large box. We kept track of that there. And so let's say we did 5 times 15.75. So it doesn't matter which equation I choose. Plus 3y equals 99. So I'm going to do 15.75 times 5. That's 78.75. I'm going to subtract 78.75. Objective is to get y by itself. Keeping things balanced on both sides of my equation. 99 minus 78.75 gives me 20.25. Divide that by 3. Y equals 6.75. Okay, so that would be my small boxes. I kept track of that there. All right. 1575 and 675. 1575. Come on. Before I forget. 1575 and 675. Hopefully I remembered those. And that's it. Okay, problem number 3. Caitlin will rent a car for the weekend. She can choose one of two plans. The first plan has an initial fee. You know what that reminds me of? Y-intercept, a starting place, and costs an additional 13 cents per mile. That would be a rate or a slope. And then we have another situation for the second plan. So let's go ahead and write an equation for the first plan. So let's call it y. That will be like the cost of the total cost we're going to pay equals 13 cents times the miles plus the 49 starting place. I put it in y equals mx plus b form there because it makes sense to me. There's my y-intercept is 49, and then I'm going up by a slope of 0.13 per mile. That's up 0.13 over 1. All right, second situation. The second plan has an initial fee of 44. There's my y-intercept. Costs an additional 0.17 per mile. There's my rate. Y equals 0.17x plus 44. So I have two lines happening on the graph, and I want to know for what amount of driving time do they cost the same. That's where my lines intersect. So one starts a little lower and goes up a little steeper. That would be the blue one. And then the green one starts a little higher and is just a little less steep. And so at this point right here, they cost the same. So I want to solve the system to see where they cost the same. This is in a nice form. Y equals something and y equals something. So those two somethings can equal each other. Or I can think about substituting one of the expressions for y into the equation for the other y. So actually they end up equaling each other in this situation. And then I just need to solve these. I can make some choices as to what I want to work on first, but the objective is to get the x's together. And on one side, see, I got that to cancel. I got my numbers together. It just was the easiest step to me. But I'm going to need to get my x's to all be on one side. Oops. That is that, and this is 0.04x. So I'm dividing by 0.04. Okay. 5 divided by 0.04 is 125 equals x. And what was x? X was the miles. X is the miles where they're the same. So that's actually going to be this one. And I want to know what the cost is when they equal the same. That means I can put my 125 into either equation and it's going to work just fine. So let's put y equals 0.13 times 125 plus 49. It will also work to put it in the other equation. 0.13 times 125 plus $49 that I had to pay from the beginning. Y equals 65.25. 65.25 when they cost the same. So 125, 65.25. Oops, come on. I don't know why we're being just a little persnickety here. 125 miles. Oh, I hope I remember this right. 65.25. Check. All right. Next. 2 mechanics worked on a car. The first mechanic worked for 10 hours. The second mechanic worked for 15 hours. Together they charged a total of $2,225. What was the rate charged per hour by each mechanic if the sum of their rates equals 180? So I have two situations here, and if I can pick these out, it's a pattern that works for a lot of word problems. So if the sum of the two rates was 180, let's call mechanic 1 x, and let's call mechanic 2 y. So I know that x plus y is going to be 180. And then I know something about the rates and what they total up. So 10x plus 15y, that's $10 per hour, or 10 hours times the rate that the first mechanic charges, plus 15 hours times the rate that the second mechanic charges, is going to total up to be $2,225. This is my system. So I can choose how I want to solve this. And it says that I can use a graphing calculator to make the calculations easy. If I'm using Desmos, then that's super easy because I can just type those in. If I'm using a graphing calculator, I have to have them be y equals something. So let's pull up Desmos just for fun. Okay. Oh, I see. It doesn't want... Well, maybe I can carry on here. Desmos, if I say x plus y, x plus y equals 180, there's my line for that. And the second one was 10x plus 5y. Oops, that needed to be a 10, equals 2,225. Oops. 2,225. Oh, interesting. What happened here? It appears that they charge the same rate because it seems like it's the same line, right? 10x and 5y is that. So let's see what that would mean for us in our problem here. If x plus y is, let me just check that. I think I saw something here. X plus y isn't 10. X plus y is 180. Doop, doop. Uh-oh, where'd we go? Way out there. Oh my goodness. Okay. And wasn't that a 15? I just seem to have messed up all the way around. Okay, that makes a lot more sense. And we've got this point right here where they are the same. 95 and 85. One is x and one is y. And what happens is our axes, one is x and one is y. So one is actually mechanic 1 and one is actually mechanic 2. So this is the number that is going to show us, let's see, go here, doop, first mechanic, let's see, one of them worked for less time and one of them worked for more time. Oh, mechanic X and mechanic Y. So if I did it in the right order, then my coordinate numbers should show that 95 and 85. Okay. And that was correct. All right, let me pull up my work there again, because what if I needed to put that or do that without a graphing calculator? I could. So if I rearrange this one, let's say I subtract x from both sides, I could have y equals 180 minus x. So I have something that I can substitute in the other equation. So I would have 10x plus 15 times 180 minus x equals 2,225. And I can do this math. 10x plus 15 times 180 is 2700 minus 15x equals 2,225. And we need to put things together. So the 10x and the negative 15x makes a negative 5x. And I can subtract 2,700 from both sides. And I get negative 5x equals 2225 minus 2,700 gives me negative 475. I'm going to divide by negative 5. Sorry for going sideways here. X equals negative 475 divided by negative 5, which is 95. So that is saying that the first mechanic is 95. And then I could take that to plug it into this equation. 95 plus something is 180. So I'm going to end up doing 180 minus the 95 is 85. So y equals 85. So there's my other mechanic. And yeah, that should be good. All right. This is a video, so let me find my actual problems that I'm working on.